When we talk about developmental dyscalculia, we often forget another important piece of the puzzle, and that's mathematics anxiety. And actually, we know even less from a research perspective about mathematics anxiety than we know about developmental dyscalculia. What we are seeing in my lab is that children who we think have developmental dyscalculia almost invariably also have very high levels of math anxiety. So the cognitive and the emotional piece, they go together. They cannot be separated in some ways. We're starting to understand a little bit about the cognitive correlates. And one of the interesting things that has emerged is that when adults with math anxiety do math problems, they almost seem to be doing two tasks at once. One of the tasks is trying to solve the math problem, and the other one is dealing with their anxiety. Dealing with ruminations, oh, I'm terrible at this, I'm not going to be able to do this, I don't want to do this, this is the worst thing, why did they ask me to do this right now? And these intrusive thoughts are consuming working memory resources that they would otherwise devote to doing the math problem. So in a sense, dealing with your emotional stress affects how much cognitive resources you can dedicate to solving the math problem. And I think that has important instructional implications then as well, is because teachers need to be sensitive, obviously, to the emotional impacts of developmental dyscalculia, as well as trying to deal with the cognitive consequences of that and how to tackle those. These individuals, it influences the way they think about their own learning, and Carol Dweck has got this concept of mindset and a fixed versus a growth mindset, and that students develop certain beliefs about the way they learn. And one of the most common beliefs in North American culture, at least, is that we've got fixed mindsets, that we're good at one thing, we're bad at another thing, and the things that we're bad at are best avoided, and we best don't, we don't need to work at them, or even if we tried, we wouldn't succeed at improving them. And you could imagine, and this needs to be tested, is that individuals with math anxiety have a very fixed mindset about their math abilities, and they don't touch them. And I think that has massive implications for their lives in the now, but also in the future, because they won't pursue careers in science, technology, engineering, and mathematics later on if they've constantly put that one thing to a side. Now, the idea is that maybe with something like Carol Dweck's intervention programs, you could help math-anxious individuals, math-anxious/dyscalculic individuals, change the way they think about math and the way they think about their own ability to acquire math skills, and shift them from a fixed mindset into a growth mindset. I'm really interested in a new emerging field called mind-brain and education, where the idea is that research in education, in neuroscience and psychology can inform each other, and through informing each other can also potentially inform practice. But over the last 2 decades, we've made tremendous insights into brain development, into neuronal plasticity, so the ability of the brain to change in response to experience, in response to inputs. And one of the most powerful inputs in a child's life is education. So education shapes the brain. Teachers are orchestrators of neuronal plasticity. So for me, it's a no-brainer that the brain should play a role in education. There's a lot of new knowledge that teachers need, and they also partly need it to be able to evaluate what's good and what's really terrible. There's a lot of terrible products that are flooding the market. The idea of brain training, brain gyms, there's lots of neuromyths, the idea that some people are more left brains, others are more right brain. Even the idea of learning styles is very, very complicated if you look at the research literature, or that we only use 10% of our brain. And so I think there is also an important role in trying to fix some of the misconceptions, because those misconceptions have the potential of actually hurting students rather than benefiting students. Take, for example, the work of Carol Dweck. One of the ways she's using neuroscience is to teach students, adolescents, about neuroscience, the notion of neuronal plasticity, that your brain can change, that if you work really hard, your neurons form new connections, there's synaptic plasticity, and she uses that teaching style to help them change the way they think about their own brains and the way they can change them, and that's very powerful. My experience is that teachers are longing to get this knowledge. They are interested in it, and they are not always just asking, what can we immediately do with them, but it enriches their understanding of the students that they teach in their classrooms.